Okay, good morning. So today we're looking at Mathematics Paper 2, the May-June 2021 paper, the Department of Education's rewrite, or the ABETS paper. Okay. The memo of this paper is not available as yet. However, if I had made any mistakes or there's an easier way of doing things, please call me on that number. Otherwise, these videos are free. What I will be doing is I'll put the videos all in at one point. So there will be a folder that I will do the QR in the last video, or I'll give you a link with the link to the folder. Okay. Otherwise, if you don't get it, you can get me on that number. I will send it to you over WhatsApp or otherwise. Okay, so we're looking at question 1. So in question 1, we are told that Sam recorded the amount of data in megabytes that she had used on each of the first 15 days in April. The information is shown in the table below. Okay, so the first question normally in paper 2 is your data handling, okay, statistics. So the numbers is not given in ascending order. Can you give it to me in ascending order? What is it? 3 yes, 10, 12, 13, 15, 16, yeah, 18, 20, 24, 26, 34, 40, 58, 69. Okay? You don't have to write the numbers in order. Okay? It's just going to make things a bit easier for you. Alright? If you want to calculate the range and how many values lies within one standard deviation of the mean and things like that, it makes it a bit easier. Okay? But it can be done without writing the numbers in order. Okay? So the first question says calculate the mean for the data set and thereafter standard deviation. So now normally when you calculate the mean, we add up all the numbers. In this case, you will divide it by 15. However, since the second question is for standard deviation, I might as well just use the keys on the calculator, or to program the calculator to get it rather in that form, and then you take it from there, the mean from there. Okay? This is going to make more sense. So what we're going to do is we're going to program our calculator. Let's get the calculator. Right? So to get the calculator in the mode we want it to be, to program it, we press mode, 3 for stat, 1 for variance. Alright? So at this point we need to enter the data. So it's 3 equals 10 equal 12 equals, so we're entering the data now. 13 equals 15, 16, 17, 18, 20, 24, 26, 34, 40, 58, and 69. Okay, so we entered all 15 values. As I said, you don't have to enter it in arithmetic or in ascending order. You could have entered it from the table, from the given information in the table as well. Okay, so you don't have to have it in ascending order. So what we do thereafter, we press AC, all clear. Then we press Shift, number 1. We would like to activate the stat key in yellow. Any yellow key on the calculator, you press Shift first. Any maroon or red key on the calculator, you press alpha, which is next to Shift. Thereafter, we want the variance, so we press number 4. Number 1 tells us the number of entries we have entered. If you press number 1, you should get 15. Number 2 is your mean, and number 3 is your standard deviation. So you press 2 equals, so your mean is 25. Is that correct? You get the same value for your mean. Yeah. 25 is correct. And the standard deviation, you press shift, 1, 4 for variance, 3 for standard deviation, gives you 17,65. Your standard deviation is a small, is lowercase s in the Greek symbol. That's your standard deviation, which is 17,65. Okay. So the next question says, in number 1.1.2, we are told that determine the number of days on which the amount of data used was greater than one standard deviation of the mean. Normally the question is, calculate the number of days that the data lies within one standard deviation of the mean. And what we do is, we normally would say our mean minus your standard deviation, your mean plus your standard deviation, and we take the range between that and count the values that's lying between them. However, here they're asking you that was greater than one standard deviation. So it must be greater than this point there. Okay? So what we need is, we need to know what the mean plus one standard deviation is. If it had said 2 standard deviations, I would have put a 2 there. If it had said 3 standard deviations, I would have put a 3 there, and so on. Okay? So that wasn't the question. The question was more than one standard deviation. So the upper end of this range is going to be your mean, which is 25, plus 17,65. So we put that in our calculator. So it's going to be 17.56, so 65. $17.65 plus 25. I know most of you can do this in your head. Not so young as you guys. So it's 42,65. Okay. So we must count how many values are above that value. So if you got this in ascending order, so 40 is below, whilst 58 and 69 is above. So to answer the question says determine the number of days of which. So how many days? Therefore, 2 days is above one standard deviation of the mean. Okay, that's fairly simple. The next question in 1.1.3, the question says calculate the maximum question is to calculate the maximum total number of data that Sam must use for the remainder of the month if she wishes for an overall mean of April to be 80% of the mean of the first 15 days. Okay? So to work out the mean for the first 15 days, we have calculated that already. So how do we calculate our mean? The mean is always the sum of the numbers, of all that 50 numbers, divided by the number of numbers, which is 15 in this case. Okay? So to calculate the sum, what does that sum add up to? So the sum is equal to your mean times n. Okay? So for the first 15 days, your mean worked out to be 25, not so, yeah, 25 times 15 days. Okay? Now we need to work out this the mean of the remaining 15 days. And how do we do that? It's going to be x. Let's say she's doing x megabytes per day for 15 days. Okay? Which month is she referring to here? April. How many days are there in April? 36? 30 days as September, April, June and November. The rest as 31. Besides, February we've got 28. Or 29 on the leap year. So at this point we needed to know that April had 30 days. Or did they tell us that? No, they didn't. Okay? So, once we got the sum of all these numbers, I can divide by 30 and it will give me the mean. Not so. But we are told that the mean must be 80%. So that's going to be 0.8 times 25. Okay. So from here it's a matter of solving for x. You see that? So what I do is I put that over 1, so I cross multiply. So 25 times 15 plus 15x equals 30 times 25 times 0.8. I'm sure you could have put this in a calculator already at this point. So 15x is equal to, let's just put it in a calculator, otherwise we're writing a lot of things here. So it's going to be 30 times 25 times 0.8 gives us 600 minus 25 times 15, I don't want to guess, 375. So x works out to be 600 minus 375, which is 225 divided by 15. I think it's 15. Okay. Yeah, it's 15. That gives us an answer of 15 megabytes at average per day. Okay. Now in question 1.2, we are told that the wind speed in kilometers per hour and temperature in degrees Celsius for a certain town was recorded at 4 o'clock or 1600 hours for a period of 10 days. The information is shown in the table below. So we've got wind speed in kilometers per hour. The first question says determine the equation of the least squares regression line. Now the least squares regression line is also the line of best fit, but that's what they use, the least squares regression line. Okay? Well, they call it least squares or they call it regression line. It's all the same thing. Again, we need to program our calculator for us to retrieve this information. Okay? I'm sure there's a way to do it manually. It will take a very, very long time. Okay? If you make one mistake, of course you're missing the whole time. Okay? Also, these questions are precise questions. Okay? You must get exactly these values. So, if you have time, if I'm you, I would take my time to enter it into the calculator, or I would do it twice. Okay? I'm sure you won't make the same mistake twice. Okay? You do it twice to ensure that you definitely bag the 3 marks and later on the 2. And further up in question 1, your standard deviation mark and your mean mark also. Okay? So how do we get it to calculate the least squares regression line? Again, if you want to clear your calculator and your calculator is acting up, you press shift 9, sorry. You're going to all clear 3 equals, and there we go. Back to factory settings or default settings. Okay. So again, to get it in the form of to calculate the least squares regression line, we press mode 3 for stat 2. 2 indicates a plus bx. Okay, it's 2. So now we have 2 columns. The wind speed is x and the temperature in degrees Celsius is y. Okay, so let's enter the data. We got 2, then 6, then 15. Oops, that's 5, 15, 20, yes, carry on. Yeah, 17, yes, 11, 24, 13, yes, 22. Okay, 22 is correct. We move the cursor over, press down arrow, so we back up on top. We've got 28, 26, 22, 22 again, 16, 16, 20, 24, 19, 26, and 19. Okay, so there we have entered all our data. So now we press AC to store the data. So AC. Now we press Shift. Number 1. If you want to see if you had made a mistake, you press number 2, you packet the data. But we want to calculate the regression line. So it's number 5. Okay? So A, number 1 is A. Remember the equation of the regression line is in the form of y is equal to A plus bx. Okay? So you press A, which is 1. Gives you an answer of 29,35. 29,35. Your B value, okay, this looks like it's decreasing, so it should be a negative. So you press Shift, 1, 5 for regression, 2 for B, gives you negative 0,48 x. Okay, so that's your equation of your least squares regression line. Okay, for 3 marks. Then in question, just pull this up as well. So in question 1.2.2, the question says, predict the temperature at 1600 hours if on a certain day the wind speed, now the wind speed is x here, which is this x thing. Can you see that?
Yes.
If the wind speed is 9 kilometers per hour. So in other words, we got the formula. So you substitute the formula. So it's 29,35 minus 0,48 times 9. So we got 29.35 minus 0,48 times 9. That gives us approximately 25,03, which is approximately 25 degrees Celsius. Okay. And the last question for question 1 is interpret the value P in context of this data. So, just to give you an idea of how this graph will look if I had to draw this graph. What do you notice? As these numbers are increasing, these values are actually decreasing. Can you see it over here? So in other words, if I had to draw this graph, it's going to cut at 29, something. The graph is going to do that. It will be decreasing. Okay, not at such a steep pace, but it will be decreasing. Okay, that angle is at about 145. The 135. Because this is very close to half, negative half. No. Just check quickly, the arctan of 0.5. That's 26. Yes, it's not that steep. It's not that steep at all. There's a gentle slope in the negative direction. Alright. I was thinking of 1. 1 is at 45. But anyway, what happens is the graph is decreasing, which is, it will look like something like that. If this is if 30 is just about that, it's decreasing at a rate. So it's decreasing at the rate of 0,48. The B value they're referring to is that B value. Okay, so we can say it's decreasing at a rate of
Good afternoon, may I have your attention please? The RCL nomination forms are still available at the office. Just a reminder that the closing date is on Friday.
Okay. So that now brings us to question 2. Where's question 2, right? Okay, so we're looking at number 2, question 2. We are told in question 2, the number of days that the grade 8 learners were absent at a certain high school during the year was recorded. The information represented in the table below. This information is represented in the table below. So, the number of days absent from 0 to 5 is 34. Including 5 to 10 is 45. Including 10 to 15 is 98. Including 15 to and so on. Okay? The question says, write down the modal class for this data. So what is the modal class? The modal class, yes, the class that has the most in. So the modal class in this case that has the most in is from 10 to 15. So x is greater than or equal to 10 but less than 15. In number 2.2, the question says, how many learners were absent from school for less than 15 days? So for less than 15 days, so it has to be, at this point, is less than 15 days. Not so. So we're going in that direction. Okay? So the learners that was absent for less than 15 days is going to be 34 plus 45 plus 98. So that gives us 177 learners. Okay? Then, in question 2.3, they want to know how many grade 8 learners are at the school. So it's just the total of your frequency, not so. Okay, so we can total up the frequency, we can add these together, or we can form our cumulative frequency polynomial. Okay, remember this is your frequency here, your cumulative frequency. Now I'm sure we're going to need it for our algebra graph anyway. So 34 is going to give us 34. The next one is going to give us 34 plus 45. It's going to give you something 79. 79 plus 98. So 177. We just calculated that. 177 is going to give you 0, carry 1. That is 8 is 12. 220. 227. 230. So in other words, there are 230 grade 8s at the school. Okay, any confusion there? No? In 2.4, I'm just going to bring this up so we can keep the data sheet, the data in focus. Okay. Data won't be in focus. Okay, let's do it. Okay, so the question says draw a cumulative frequency graph, the OJ, to represent the data above on the grid provided in the answer book. Okay, what I did was I drew my own grid here. Right. Let's make it a bit smaller. Take this away. Okay. So if you look at the interval, this is our interval, or number of days absent. Okay. We see we go from 0 to 5, then 10, 15, 20 and so on. So I go 0, 5, 10, 15, 20, 25, 30. What's the maximum here? 30. So yes, that is enough. And on this area, it's your 30 mark. Okay? We always try and use the most of the axis all the time. Okay? So the bigger the graph is, the more accurate the graph would be. Okay? So your interval there is going to 30. Your cumulative frequency, okay? Your cumulative frequency, we've got on your y-axis and it comes in at 230. So your cumulative frequency, okay? So 230, with the divide 230 by 10, I get 23. So let's make it 25. So it's 25, 50, 75, increments of 25. It's 100, 125, 150, 175, 200, 225, 250, 270. Is that correct? Okay. So that's 4. 1, 2, 3, 4. Yeah, that's correct. Okay. Any confusion as well? So when we draw this graph, we draw the end point and the cumulative frequency. So the points to be plotted is 5 and 34. Then 10 and 79. Not the midpoint, the end point of the class in the cumulative frequency. 15 and 177. 20 and 220 and so on. Okay? So the first one is 5 and 34. Let's go 5 and 24. Now 24 is just less than 25. Not so? So it's there. The next one was 10 and 79. Not so? 10 and 79. 10 and 70. Does it 75? So it's just above 75, 79. Then 15 and 177, which is just above 175. Then we got 20 and 220, which is just less than 225. That is 225. So 220 is 5 units less, or a few units less, approximately there. It's all by approximation. 25 corresponds with 227. So it's just above that. And then 230, which is approximately there. Okay, no, nothing. On the last part, no? 230. So what we do now is we connect the dots with a smooth curve, freehand. We do that. Okay, it's going through there. So what we do is we now ground the graph to the starting value of the first interval, which is 0. Let's have it there, no? And that is your ogive graph, or your cumulative frequency polygon. Okay. Then, here's another question, yes? That is your last question. Now make it so that I don't run out of space, because here I have too much space now. So it says, use your cumulative frequency graph to determine the median number of days the grade 8 learners were absent. So the median is the middle number of sorted data. Are these numbers sorted? Yes. Okay. So for the median, how many values are here? There are 230 in total. Not so? So this must be the middle. Then divide by 2. 230 divided by 2 is 115. Not so? So now we go to the 115th number. So that is 100, that is 125. So the middle of this is 12.5. Not so? So it's just above the middle of that. No? So 112.5 is in the middle. So 115 is just above that. So I'm going to go with just above that. And what do I do is I go until I take my ruler, put it horizontal with this axis here, parallel to that axis, horizontal line. I go across until I hit the graph. Okay? Then I turn the ruler vertical or parallel to your y-axis, your cumulative frequency bar, and I go down here. And I take the reading that you have there. Okay? And this is your Q2. And if this is 10, 15, then this has to be 12.5. Not so. And this is, according to my graph, less than 12.5. So I can say it's going to be 12 or 11 or whatever comes approximately. Okay. Now everybody's graph will be a bit different. So if you came to 13 or 14, but according to your graph it is 14, then you'll get a mark for it. Okay. However, it's going to be a total over 15 or a total under 10. Of course, you can't do them. Okay, because these values are governed by those points, which is then in correspondence with those values. Make sense? So therefore, that would be acceptable. So therefore, your median mark is, as I said here, is going to be, say, 12. Okay. So that basically brings us to the end of question 2. Okay. Let's go to question 3. In question 3 we are told that, make this a bit smaller. In question 3 we are told that in the diagram S, which is 0 and make this a bit smaller. We're told that S, which is 0 and negative 16, and here we find S to be there. L, which is there, and Q, which is 4 and negative 8, are vertices of triangle SLQ. Okay? Having LQ perpendicular to SQ. LQ is perpendicular to SQ. And SL and SQ produce 2 point R. So SL and SQ are produced to R, that one's going to R, and that one's going to M respectively, which means to say in that order, such that RM is parallel to LQ. SM produced, which means to say extended, SM is produced to cut the x-axis at N, which is 8 and 0. Then we are told that MQ is equal to NM. So that's the midpoint of those two values. T and P are vertices of the y-intercept of RM. So again, T and P are the y-intercepts of RM and LQ respectively, which means to say again, in that order. Okay? So all the information that is given in the write-up is again given on the diagram. Okay? So we can take that out. So let's see what's the first question. The first question. Sorry about this. Right. So the first question, so I'm going to keep the diagram in focus and just delete the questions there at the bottom, okay, and fill in the information on the diagram. So the first question says calculate the coordinates of M. So you look at M, there is M. So what is M? M is the midpoint of QM. How do we work out midpoint? Midpoint formula, which is x1 plus x2 over 2, y1 plus y2 over 2. Okay, so you're going to go with Q. It's going to be 4 plus 8 over 2 and negative 8 plus 0 over 2. Which then give me 4 plus 8 is 12 divided by 2, 6, and that's going to give you negative 4. Does it make sense that when it comes to analytical geometry, it must make sense? Okay, because it can be drawn, and as you can see here, it is in the fourth quadrant. X is positive and y is negative, and of course it can't be less than negative 8, and your x value can't be more than 8 or less than 4. So 6 makes sense. Okay. So that's the first question for 2 marks. 3.2. In question 3.2 we are told calculate the gradient of NS. How do you calculate gradient? Change in y over change in S. But if we look at NS, which is this line here. People, in analytical geometry, there's many ways to work things out. Okay, many ways. So, to calculate NS, do we have 2 coordinates on NS? Yes, we've got many. We've got 4 coordinates. So there's a lot of combinations. It's probably 12 different ways I could have worked it out. Okay. So that's going to be 1, 4, 5, no, 6 ways, not 12. Okay. So that's going to give us the gradient of NS. Remember, if I work out the gradient of NS, it's the same as working out the gradient of QM, which is the same as working out the gradient of SQ, and so on and so on. Why? Why is that the case? Because these points are same line. What do we call that? Collinear. If points lies on the same line, it is collinear. And if they ask us to prove things are collinear, we prove that the gradients are equal. Okay. So change in y over change in x, y2 minus y1 over x2 minus x1. People, many a times in the finals or in the exams, we have people writing the formula, but when they do the substitution, they put x2 minus x1 over y2 minus y1. Don't make that mistake, okay? Or they swap one of the two around. So you got negative 4. No, not negative. I'm going with S and N's coordinates. Okay, as I said, I could have used the others. So it's going to be 0 minus 16, which is 16 over 8 minus 0, which gives you a gradient of 2. What does that tell us? That tells us the gradient is positive. If it's positive, the line must lie to the right. And is it lying to the right? Yes. So that seems to be okay as well. Alright. Then the question says, just get question 3 here. In question 3 we are told, show that the equation...
Can you please report to the office? Kira from Drill, please report to the office.
Okay, so the question says show that the equation of LQ is defined as y is equal to negative a half x minus 6. Now if it says, if you got to prove that, to show that question, do not write this down. Okay, we must end off with that. Okay, you can't use that in pursuit of calculating or proving that that is the equation. So if you investigate and see where's LQ. So LQ is here. And what's the relationship, or what do we need to calculate the LQ? It's the equation. I need the gradient and I need another point on this graph. Do I have the gradient here?
We
You can find it. Wow.
perpendicular.
Perpendicular. So what's the relationship between lines that are perpendicular?
The gradient
The product of the two gradients?
is equal to
Negative 1.
y.
So the negative 1. If they had said it was parallel, then what do you know? The gradients are the same. Okay. So the gradient of NS times the gradient of LQ must be equal to negative. But we know what the gradient of NS is. It is 2. Not so?
Yes.
So it's going to be 2 times the gradient of LQ is equal to negative 1. So the gradient of LQ is equal to negative 1. Okay. But have I answered the question? No. So what do we do now? It must be in the form of y equals mx plus c. Not so? But the equation, but we got the gradient. So y is equal to negative half x plus c. So at this point we're going to substitute a point that's lying on this graph. And the only point we have that's lying on the graph is 4 and negative 8, which is also your q value. No? So we'll substitute your q value. So we'll substitute q, which is 4 and negative 8. Remember again, that's a x and a y. Okay, that's a x and a y value. Let's just cut it. Okay. So x and y, so it's going to be negative 8 equals negative half times 4 plus c. What is negative half times 4? Negative 2. Putting negative 2 over the equal sign becomes plus 2. So c is equal to 2. So therefore y is equal to negative a half x plus, no, I made a mistake here. C is not 2. C is 6. In the negative. So that is 2. Negative 2, take it over, becomes positive 2. So you're going to be negative 6. So y is equal to negative half x minus 6, which confirms that there. Not so? So that basically has been confirmed in that calculation. Alright, so what I'm going to do is I'm just going to fill in. Okay, I got m already there. So I'm going to take this information off the graph now, off the board. So that the gradient of NS is going to be 2. And we know that the equation of this line here is defined as y is negative half x minus. Alright, so let's just clear the board. Okay, let's get here 5, yes, 6, 7. Alright, so in question 3.4 we are asked, determine the equation of the line having, determine the equation of the circle having center at O, the origin, and passing through S. So if you have a circle, center at origin and passing through S, this is what the circle is going to look like. I think I'm start. That's it. So that's basically what you have to see. Okay? So the equation of the circle center at origin will follow the formula. What will the formula of that be? X squared plus y squared is equal to r squared. How do you calculate r? We need a point that's lying on the circumference of the circle. Do I have such a point? Yes, S. So you will substitute S, which is 0 and negative 16. Again, that's a x and a y. So 0 squared plus negative 16 squared is equal to r squared, which is 256. Not so? So we got x squared plus y squared is equal to 256. Otherwise, we could have also noted that your radius, and your radius is 16. So 16 squared is 256. That's why they give you 2 marks for that sum. Okay. Any confusion? No? Let's take the circle off here. No, okay, this line do that. Why is this thing picking it up now? Which sum are we on? 3.4, no? So that is, we just did that now. For some reason the table. Okay. For some reason the mouse picked up to that. Something we didn't want it to pick up. Okay. We're just going to delete all those questions quickly under, so there's a short question. I want it to stick out at the end. Okay. So here we go. In question 3.5, we are told calculate the coordinates of t. So what is t to us?
T is the x and y intercept.
T is the y-intercept. Okay? It's the y-intercept of what?
Of line RM.
Of line RM. But we know that RM is parallel to
LQ.
LQ. Okay, now there's many ways of calculating t. You can go into Euclidean proportionality and similarity if you want to, in that topic. But I'm just going to do it using the equation of the statement. Remember, t is what? T is your y-intercept. How do you calculate y-intercept? With x to 0. X is 0 of that equation of that line. So what we say, y is equal to mx plus c. But what's the gradient of this line? The same as this y, because the lines are parallel. Lines are parallel, gradients are equal again. So it's negative of x plus c. Now do I have a point this line on this line? Yes, I have 0, no, not 0, and 6 and negative 4. So you'll substitute m, which is 6 and negative 4. It's a x and a y. So negative 4 is equal to negative half times 6 plus c. Now this is going to give you negative 3. Eh? Bring it over, becomes positive 3. So your c value is negative 1. And I know my c value is your y-intercept anyway. So therefore, t is going to be 0 and negative 1. Makes sense, people? And again, it's clear, it makes sense. Alright. Let's see what question 3.6 entails. In question 3.6, we are asked to calculate, and let's go with green, 3.6, they want to know LS over RS. LS.
Mr. Engel, can you please buzz the office? Mr. Engel, please buzz the office.
Over RS, which is that line. So again, that is line between two parallel lines. Not so, this is forming a triangle. Not so? So, we know that LS over RS is equal to SQ over SM. I can't work out the length of SL and RL here, or R S here, because I don't have these values here. Not so? So I must use proportionality theorem. Not so? Otherwise, you can also consider this here. We got LS over SR is also equal to SP over ST. Can you see? Because this is also a triangle here. Not so? And it's going to be easier to work with those two. Not so? So I say that LS over RS is equal to SP over ST. Now I don't need the reason here. Why? Because it's not analytical, it's not Euclidean geometry. Unless the question specifies, you must state the reason. Okay? So as you can see, the question was not specified, so we do not have to state the reason. Okay? Again, if I had any issues here, please contact me on that number. So at this point, I'll just check again. So we need to, in other words, know what SP is, or ST. We know what ST is. ST is going to be from S to T. Remember, this is negative 16 and negative 1. So what's the distance between those two values? 15. Alright. Now we need to know what P is. But where am I going to get the coordinates of P? From the equation of that line. Not so. So the P's coordinate is 0 and negative 6. Not so. Because your y-intercept, you see value of your straight line. So what is the length of PS? Therefore, PS is going to be from minus 6 to negative 16 is 10 units. So if I substitute that information back now, then you substitute that back now, then LS over RS is equal to SP, which is 10 over 15, which is 2 over 3. Okay. Otherwise, I said there's many ways of doing that. Okay, you could have worked out the distances of, I think that was the first sum that I explained. You could have worked out the distances and then go again with proportionality theorem. Okay, and there's a class outside, so just need to wrap this one up quickly. We just let them in first. Okay, so the last question, we'll just take this off first. So the last question says calculate the area of PTMQ. PTMQ. I think I would need to know what these values are. I was going to leave that in. So P. Okay, now the diagram is overpopulated. There's a lot of writings on the diagram already, which is fine. We just need to look past it. So we got T, P, M, Q. So we got T, P, T, P, M, Q. So that is the diagram. That is the quad that needs to be calculated. So to calculate the area of a trapezoid, a trapezium, that's a trapezium being formed there. How do we know it's a trapezium? It's going to be, you got two parallel lines there, and it's a quadrilateral. So it's a trapezoid or a trapezium. The area of a trapezium, area is equal to half Some of your parallel lines, which is in this case TM plus PQ, the distance thereof, times your perpendicular height. Now your perpendicular height here is QM. How do I know it's perpendicular? Because of the 90 degree. Because angles on a straight line. Okay? A lot of geometry coming into play here. Okay? So it's going to give you QM. That is one way. And there's many ways of doing this. Okay? I think there's like four or five different methods of calculating this. We could have cut this up here at that point and formed a rectangle and a triangle here. You could have worked out the area of the rectangle plus the area of the triangle as well. And as I said, there's many ways of calculating this here. I think I'm over-exaggerating when I say 4. I'm seeing 2 now, okay? The 3, we had divided that way. And I'm sure there's more, okay? So I'm not going to waste time looking for all the different methods. I'm going to apply this method. So this came to mind first. Okay, so what I'm going to do is I'm going to say the area of the length of TM. Okay, as I said, the diagram is overpopulated. So I'll just pull this out here. So for TM is this length here. So of course, distance formula. So TM, this is now for 3.7. For TM, it's going to be the distance formula. So it's going to be the square root of 0 minus 6 squared plus negative 1 minus 4 squared. Minus 4 squared. So that's going to give us an answer of square root of, kind of get it out of stat mode first. So I pressed mode and 1. So the square root of open brackets 0 minus 6 squared plus open brackets negative 1 plus 4 squared gives us 3 root 5. Okay? So that's going to give you 3 root 5. I think the calculator is in the way again. No, it's not. Okay? So that's going to be 3 root 5. So remember, now I need that length here as well. Okay? So PQ, the thing on top means length, equals, you don't need to put it there anyway. So it's going to be the square root of 0 from P to Q is going to be 0 minus 4 squared plus negative 6 minus 8 squared. Minus 8, so positive 8 squared. That now gives us, again, square root, open brackets, negative 6 squared. We could have just said 36. No, it's 4. So not 6, 4. Plus, open brackets, negative 6 plus 8 squared. That gives us 2 root 5. Okay? Which is this length here. 2 root 5. Your perpendicular height here, QM. Same story. Distance formula. It's going to be 6 minus 4 squared. Pull this up here a bit. 6 minus 4 squared plus 6 minus 4 squared plus negative 4 minus 8 squared. Okay, again we put that in the calculator. Open bracket 6 minus 4 squared plus negative 4 minus plus 8 squared gives us 2 root 5. Okay, so we put that next to it. So it's 2 root 5. Okay. Now we can now substitute that back into the area formula. So area is equal to half TM, which is 3 root 5, PQ, 2 root 5, QM 2 root 5. Okay, so 3 root 5 plus 2 root 5 is 5 root 5. So it's a half 5 root 5 times 2 root 5. I'm sure at this point you're going to put it in the calculator already. So that's going to give you the half cancels that. So root 5 times root 5 is 5. Times 5 is 25. So 25 units. Square is the answer to question 3.7. Okay. So that basically brings us to the end of this video. Okay. Again, if there's any problems or mis-explanation that I did, please contact me on that number. Otherwise, the folder is available to send me a WhatsApp message, and I will send you the folder to all these videos pertaining these papers. Okay.